All right, let's do a Leetcode question. I've found this one at random. I just started looking at it, but let's look at it together. And basically, I'm going to go through this as if I'm doing a mock interview. I chose an easy Leetcode question that's an algorithm-based one. And I'm going to try to talk it out as if I'm doing a technical mock interview as a candidate going for a entry-level position. This is not so much about solving the problem really fast, more about explaining the thought process behind it. So hopefully this is interesting to you. Here we go. So what do we got? We've got a number 2859, sum of values at indices with k set bits. You're given a zero-indexed integer array of nums and an integer k. Return an integer that denotes a sum of elements in nums whose corresponding indices have exactly k set bits in their binary representation. The set bits in an integer are the ones present when it is written in binary. For example, oh, hold on, let me start timer also. And I'm going to use a Google Doc. I know it sucks, but this is closer to what is possible when you're getting an interview. So even though it's a lot nicer to work with a IDE that does autocomplete and everything for you, it kind of hides a lot of mistakes. And especially if you get an interview where you don't have access to that, you will feel pretty out of your elements. So I'd suggest getting used to not having access to only a notepad, more or less. And honestly, it does help you like realize a lot of the mistakes you might be making. For example, there's a lot of autocompletes I have with Sublime Text or VS Code that I don't even realize. And sometimes I've done like Python ranges and I don't remember how it works exactly, but the hover and autocomplete of those IDEs really help you automatically, and you don't even really realize it. So in an interview, you might not have access to that. Anyway, back to the question. Let's say the interviewer is explaining it to me. Denotes the sum of elements in nums whose corresponding indices have exactly k set bits in their binary representation. Don't exactly understand that yet. I know binary representation, they're talking about it right here. Set bits in an integer are the ones present when it is written in binary. So set bits, just ones. If you have a binary, if you take a number and turn it into binary, count up all the ones, it looks like. So that makes sense. 21 is 10101. Has 3 set bits because you just summed up the ones. So we could just do that. That's actually kind of nice. Sorry about the burp. If we take our nums and we have 510, 152, and k is equal to 1, we'd expect our output to be 13. So I don't yet exactly understand. So some of elements I get, but which elements? The ones where their indices have exactly k set bits. So I know, does that mean each number? Let's copy this over and start talking about it a little bit. And also some of the questions I have. Oh. Let's fix that. And let's put our answer down here. And let's make this okay, a little bit smaller, a little bit more concise. So the question I have, a couple of questions I have. First off, what do indices mean here? Here, interviewer might give you more advice at this point. I'm going to assume they haven't, because I don't have an interviewer to tell me that. Another one is what's the max in bit size, bit count? What's the max size of an int? And is it fixed? Like, are these 32-bit ints? Let's just say, yes, fixed size could be 64 or whatever. And are we going to get invalid inputs? Usually with Leetcode, you don't. So for the purposes of this question, let's assume no. And how big could this array be? Can this all fit inside of memory? Again, with Leetcode, usually the answer is yes. So let's just say max length. Actually, they probably tell us. So constraints, it looks like max length is 1,000. The number, the integers themselves will be under 10 to the 5, which is 100K, I believe. So that essentially limits the number of bits we have as well. And then K, the set bit, will be limited as well. That was another question I was probably going to ask. Because what happens if k is greater than the number of bits in the nums? Then the answer, I guess, would be 0 at that point. So that's actually allowed. But in this case, they say k max of 10. Okay. So what is an indice? Are we taking each number, finding their binary representation, and then finding the number of set bits for them? What is an indices? I don't know this yet, because at first glance, what I'm seeing and thinking is that we are going to keep I'm just writing pseudocode right here, so let's just create a example count bits, I guess, of nums, which is a list of int. I'm just creating the skeleton, so we're taking in our k that we're trying to find, as well as returning the sum total of those bits. And that's another question: is sum fit in an integer? And the answer is probably going to be yes, especially considering our constraints. If this number was going to be a lot larger, like let's say each integer was at the max and you sum them together, they would overflow, then you'd want to use either a large int in like Java or something, or maybe Python you have float or some other form of representation, but that's a different question. So the one I'm really trying to figure out, what do indices mean? And I'm not sure about that yet, because what I'm thinking when I first see this, but I'm starting to realize is probably not the case. I think I'm a little confused, is could I have a total equals 0 and then iterate over values, and for each value count bits, set bits in value, check if equal to k. If yes, then total plus the value. Otherwise, else we just don't do anything. So that's kind of my first thought process. And let's just pretend we were going down this route. Iterating over values is O of n, where n is number of values. And then we're counting the number of set bits inside of that, which is going to be O, let's call this m, for number of bits. So the total would be time complexity of O of nm, because we're just doing a loop and loop for the bits and numbers, and space complexity is a single value total, so that'd just be 1. And for this one, at least, I can't see any way you'd get around that. But that has not answered my question of what is an indice. I really don't understand that yet. Let's look at this example, whose corresponding indices have exactly k set bits. Oh, so is it the number or the indice of that? So in fact, they don't care about, yeah, they don't care about the number, it looks like. They just care about the indice. So 5, we don't care about the set bits of the number 5. We care about the set bits of the indice of 5, which is 0 in this case. So that's why they're showing the binary representation of indices. Ooh, that's easier. That's a lot easier, I think, because you now know that the max number of bits is always going to be less than the actually, not only do you know that, this is going to be some sort of fixed, so first you would know that given a number n, the square root of n is the number of bits you would need, because is that correct? No, that might be wrong, sorry. You're trying to make sure that n fits within is less than 2 to the n, or sorry, 2 to the k, or 2 to the m. Let me write that out to explain what I mean by that. If your number is like 5, or let's say 10 in this case, and the number of bits needs to be 2 to the power m is greater than 10. So in that case, like 2 to the power 3 is 8, 2 to the power 4 is 16, so 4 bits for 10, which makes sense. But so that would be like 10 is just 8 plus 2, so I think that's 2 to 0, 2 to 1, 2 to 2. That's 8, and that's 9, and that's 10. But that's not even what they care about here, so I don't know. I didn't need to do that actually. But it's still good to talk it out with your interviewer. We actually only care about the length of nums, and that's the number of bits that are going to be in there. And there's probably some interesting mathematical or binary tricks for getting the indices that have the right number of set bits. We could even have a we could build a fixed. So, okay, let me just do this. There's a couple of approaches here. So first, or algo 1, we can create a, so we're at about 10 minutes in, so we've kind of started understanding the question. I've talked it through with the interviewer. I now have finally established that we're talking about indices and not the values of the array. So one brute force algorithm kind of is you create you iterate from 0 to n, where n is length of nums. And then for index for indice I, for each index, count bits, set bits, and if it's equal to k, we do the same thing of saying the total plus value. So that would be a O of m there, and this would be a O of n. So we're still at O of n, O of m. So that's one algorithm. And that's totally valid and fine. I think another thing we can do here is there might be some math trick for permutations of binary digits from 0 to n. Like, this is a fixed thing. There's only a certain way to iterate through all the binary numbers from 0 to n, and it's exactly the same. It's always going to be 0, 0, 0, like 0, 0, 1, 0, 0, 0, 1, 0, etc. And there may be I'm guessing some formula for telling if that indice is for telling number of bits in that indice. So if we had that, then we have an O of 1 instead of O of k, and final solution would be O of n. I don't know that one just yet. Maybe I'll come back to it. If the interviewer wants to tell it to me, I'd be happy to do it at that point. The third thought is, since we know the maximum length of the array is 1,000, then we are guaranteed 0 to 199 is the max length and values. We can build and store this as a constant array of bit sizes, and just have this as constant, O1. And now in our original algorithm, instead of doing a count set bits, we do a table of set bit table of that index and check if that's equal to k, and if so, do the same. So now we have a O of 1 for each index and a total O of n. So I think one could go with this one. I'd say for this type of problem you probably could, but just to assume that the problem is large enough that we aren't going to store it, let's start with algo 1, because we can convert to algo 3 after. So we're at about 13.5 minutes, 3.5 minutes in. Let's start coding, I think. The interviewer, I kind of walked through the interviewer with my thoughts on this one. Are there any other things I can think of? Can I solve Can I figure out this formula? There might be something relatively simple here. I'm not entirely sure. I think building this array might be faster than O of n times m. You could probably build it in O of n time. But I'm not sure how at this second. So unless that's critical, I'm going to start with algo 1 and maybe we'll come back to that. Okay, so I'd like to create a actually let's call this get some bits, and let's call this count bits of a indice int, or actually just value, because it doesn't really care about what it is, and return an int for output. Here we could use a fixed bit size, or we can do right shift of the bits. So let's say we have 1011. If we do we can do an AND with the first bit, and that's true. So we count plus 1. Let me walk you through that. So for while the value is not 0, we check if the value and 1 is equal to 1. So I could get rid of that because that's by default. If the set bit at the least significant bit is true, I'm just writing this for clarity, bitwise AND. That's my intent. I'm not entirely sure about that, but I think in Python AND is different. So let's just assume the single ampersand, not a double ampersand, is the bitwise AND. So if it is, then count plus 1 and return the total count like that. And I think we could actually even do a sum of value and 1 while, no, okay, let's not get too clever there. So this is a O of m operation. It'll basically keep adding to the count for every time the bit's 1. We have to then right shift the value by 1 bit, equivalent to value divided by 2. That's what I just had earlier, this thing. So basically it's just taking the bit on the right and getting rid of it. So like if we had 1011 and we right shifted by 1, we would get 101 like that. And we've just gotten rid of this bit right here. Okay, so we've got count bits. I like to do this for I in range length of, actually, let's do enumerate. So for I value in enumerate, and that just gets you the index as well as the values. If the index is equal to k, then we add the value to it, and then we return the total at the end. So we're returning the sum of elements inside of num, because here they said that indices 1, 2, and 4 have their set bits equal to 1. So the sum of those values will be 0, 1, 2, and 4 gives you 13. Okay. And if it's an empty array, what happens? Do we return 0 or do we return none? I'm going to arbitrarily propose not 0 because that's how this one will operate. Okay, and so here's one approach. This would be O of nm space complexity. Could we bring this down? Let's say the interviewer, well, first let's check that this works. I'd like to put this into the Leetcode. We're at 18 minutes, 30 seconds. So putting in the Leetcode is kind of like the interviewer double checking with me that the code makes sense and it works. And then we can start talking about optimization. All right, so what do we got? First, the sum bits here. Nums and k's the same, that's good. And I'm just putting this into the same format. That looks okay. And then this should be it. And that looks okay too. Okay, am I seeing any mistakes here? You may be seeing something that I don't. We're about to find out together. So here, as an interviewee, as a candidate, I'd be kind of trying to look through and double check the interviewers asking me questions about it. So let's see what we get. Oh, right. Sorry, this is within the solution of Leetcode. Self account bits, and in fact, this would have to have a self as well. Let's try that again. Okay, that looks good. So this does seem to work for those two cases. Let's do a submit and see how it looks. Okay, accepted but slow. So we have an O of NM. Let's see if we can optimize it. O of 1. So we're at about 20 minutes in. 20 minutes in. Talk about optimization. So here's where I'm now starting. Now that we've done algo 1, I'm starting to think about 2 or 3. One approach is we could do a one-time, let's say we can preemptively have a fixed length array. We could do like a, for I in range, in this case, 10 to the 10, I in range 1000. Sum table equals, actually, I think you could do it like this, count bits of I for, like that. And then we can just use the sum table instead of, let's get rid of these extra comments. Instead of doing a count bits here, which is an O of M operation, let's actually, let me pull this out and put this somewhere else. So here, what I'd like to do is create a table, constant table ahead of time. One time ONM op store space ONM. And if we use this table instead of count bits here, we can get it an O of 1 time. So now this becomes a O of N time, O of N space solution. So that's one other way we could approach this. Just for fun, let's see if we can do that inside of here. So I'd like to try that out. I'm not sure we're allowed to do this, but let's try it. If sum table of I equals K. Let's find out. Oh, hold on. Oh, we're not allowed to put it on the outside. But yeah, that's okay. That makes sense for Leetcode. There might be a way to do that. It's unrelated, but at least you can explain it to your interviewer. Now the third one is, this is algo 3. This was algo 1. And now let's talk about algo 2. I think, well, actually, this is a version of algo 4 is build counts one time. So how do we do that? What I'd like to do here, I'm thinking about is there a way to generate this table? Well, in the call, faster than O of nm. Preferably O of n. So perhaps here we have, for example, right now we have this count bits, and I'd like to instead do some sort of I'd like to do it in here somehow. And instead of doing count bits, the idea is that we do a loop, and as we iterate through each bit, we have this fixed size list, which we know the length of it is going to be exactly what we've been passed in, the length of this nums. And we just increment that bit for each value by doing a direct comparison of that number to the bit. It's still technically O of nm because you're doing a bitwise comparison with the first one. I think it would be faster in this case, like not in time or space complexity world space, but like in practice. If the interviewer were to ask me to do this, I think that might be beyond the scope of this problem, but might be kind of fun. So let's just do a quick look at this. So let's say for I in range length of nums, sums table equals 0 times length. Let's say n is equal to length of nums, and that way we don't have to keep writing that over and over again. And so for each one, what I'd like to do is take that I and modulo it with k, or let's call this m. For m in range the max bit size, which I think we talked about earlier here, 2 to the m. So what's the inverse of 2 to the m? Not sure how you do that. X do you solve for y here? This is where we start to get a little bit into the math of things. There's probably a really simple solution that I just don't know off the top of my head. Y root x equals 2. No. I guess what you could do is you could just keep going until while true, m equals 0, and then do sums table of that of I plus I percent m. No, sorry, I and 1 shifted over by that index. So we're basically building up this sums table, and increment it. Let's call this did add equals false, and if we have actually added a value, then did add equals true, and we keep going until we've reached a m that is a bit too large. I don't think we need to do this complexity if I just knew what the how to find that m. I think it really might just be some sort of it's escaping me at the moment. Feel free to let me know in the comment. And then after we've done all that, we now have a sums table that contains all of these values. And this technically took O of n times m again, but we did it in one pass without too many. We did it O times the number of bits, and it's clever for no good reason in this case. I think it would eventually become faster for some certain cases, especially if the number of bits is fixed. So one could argue that if we know the number of bits for this nums is certain something, we would be able to make it a constant time thing. So this would still be O of nm and O of n space. Yeah, I think here it's ahead of time or a math approach. All right, I think that's all I've got for this one. Hope this was interesting to you, and feel free to let me know if there's anything I missed. There are other small optimizations and things like that probably available around here, but for the purpose of an interview, you're just trying to be clear and straightforward. You're not trying to like use too many shortcuts or obfuscate your code too much. Anyway, cheers.